All right, guys, so we're going to be looking at completing the square on a quadratic in order to find the x-intercepts of a graph. So let's go ahead and start with it. When Joey dived off a diving board, the equation of the pathway can be modeled by h equals negative 16t squared plus 15t plus 12. Find the time it takes for Joey to hit the water. All right, so we're going to go ahead and sketch this out so we can make some sense of it. We've got Joey on the y-axis, and we're going to say that that is time equals to 0. And when that happens, Joey's going to stand up on this diving board. He is going to be super excited about jumping into that water. And when he does, he's going to launch himself bouncing up, and then he's going to come all the way back down, splashing into that beautiful pool of water that in Florida has got to feel so daggone good. And one thing we do know is that he starts at 12 feet on the y-axis. Okay, so now when we do this, we're going to be completing the square, and there are some steps to completing the square. So I'm going to write everything out as we work through this process. I'm going to write negative 16 t squared plus 15t minus 12. And because we're looking for, or plus 12, and because we're looking for where he hits the, when he hits the ground or the pool in this case, which is going to be y equals 0, I'm going to set this equation equal to 0. Now, the first thing I always do is I plug this into what we call vertex form. And then what we are going to do is we are going to solve. Now, we are going to do this with completing the square. And the first thing we do with completing the square is we section off the t squared and the t. And what we do, once we have it sectioned off, we're going to divide out by the first value that is attached to t squared, which in this case is negative 16. So I'm going to divide by negative 16. Okay, and what that is going to leave me with is t squared plus, and now I do have to, let's go ahead and make life a little bit easier on ourselves. We're going to go off to Desmos. Okay. And as we go off to Desmos, I'm going to type in 15 divided by negative 16. So 15 divided by negative 16. That is going to give us it's going to give us negative 0.937 or negative 0.94. I know that's hard to read. So negative 0.94. So let's go ahead and erase this. And I'm going to write negative 0.94 t plus 12 equals to 0. Now, the second thing we're going to do is we're going to take this piece and we are going to make a box, an area model with it. And some of you may remember the area model, but we are going to make a special type, which is a square. And that's why this is called completing the square. That means that both sides are exactly the same. So what I do is I take the t squared, I put it into the first box. I'm going to take the negative 0.94t and put it on the outside of the box. Okay, and once I do that, I'm going to start filling in the sides. So this is t times t, which will give me t squared. And now it is a square, so this piece and this piece that I'm drawing lines are have to be the same. And remember, when we do these diagonals should add up to that negative 0.94. Well, if they're going to be the same, all I really need to do is take negative 0.94 and divide it by 2. And when we do that, I'm just going to take negative 0.94. I'm going to divide it by 2, and that's going to give us negative 0.47. So I'm going to write negative 0.47t, negative 0.47t, and that is minus 0.47 and minus 0.47. Now, the other thing you're going to remember is that when you use the area model, you multiply to get this box right here. And that is going to be negative 0.47 times negative 0.47. So let's go ahead and write that out. Negative 0.47 times negative 0.47, which is going to be 0.22. So I'm going to write 0.22. 2, 2. Now you can see I'm changing colors because I'm going to come back to that in just a second. Now, once we've got this, okay, we have actually changed the yellow section of our equation. So we've actually changed that yellow section right here. And what I'm going to do is I'm going to rewrite it. I'm going to write -16. Write -16 in parentheses. I'm going to write t. I'm going to write it in green because that's where we're working with. T minus 0.47 squared. And that is because there's 1, 2 of them. And that's why it is squared. Okay. And I'm going to add 12 to it. Now there's one thing, and you're going to notice this, I left a piece in pink, and that's because we haven't dealt with that piece. This piece is extra. It is new. Okay, and that piece 0.22 is being multiplied by -16. Okay, it is being multiplied by -16, which is this, and it is getting multiplied into that 0.22. So what I'm going to do now is I'm going to find that value. I'm going to say 0.22 times -16, and that is -3.52. All right, -3.52 is extra. That is brand new because of this piece right there, okay? So to make it go away, since -3.52 is extra, to make it go away, I am going to add 3.52, okay? And now, some people are going, that's really crazy, but we changed the problem with this piece right here. And so it changed by that much. And so we want that to go away. So we use the opposite on the outside. So now look at what happens. -16 t minus 0.47 squared plus 12 plus 3.52 is 15.52. Now check it out. What did we get? We got the axis of symmetry 0.47, and we got the height of 15.52 just out of our equation right there. We're in vertex form, okay? Once we have this, we can actually solve it because we originally set it equal to 0. And when we set it equal to 0, that said we wanted to know when it hit pool. So that's what we're going to do now, is we're actually going to solve this equation as we set it equal to 0. So I do 0 equals -16 t minus 0.47 squared plus 15.52. And we just solve. We subtract 15.52. Okay. We get, that would give us -15.52 equals the -16 t minus 0.47 squared. We divide by the -16 as our next step. Okay. Then we just have to come back over to Desmos. We just have to figure that out. What is -15.52 divided by -16? And that is going to be 0.97. So we come over here and we say, okay, well, that is 0.97 equals to t minus 0.47 squared. Once we've got that, we're going to take the square root, because the square and the square root will cancel each other out. We get t minus 0.47. T minus 0.47 equals to plus or minus 0.97. Okay. And then we have that last step. We need to get rid of that negative 0.47 with a positive 0.47. Okay. Now, these are going to cancel, and I'm going to go ahead and erase a little bit of this over here so it's a little easier for me to see. I know we did all that extra work there. Okay. But what we're going to do now is we are going to go ahead and type in this statement, t equals to plus 0.47 plus or minus 0.97. This statement right here, this went away, and that is what t is going to be equal to. So now let's do that. I type into Desmos 0.47 plus 0.97. And then I'm going to type into Desmos 0.47 minus 0.97. So let's go ahead and do that. We go to Desmos, let's type that in. Okay. 0.47 plus 0.97 and 0.47 minus 0.97. Now, check it out. You'll notice that one of the answers is 1.44 and the other one is negative 0.5. Remember, these are x values or time values, okay? So these are time values. One is 1.44 and the other one is negative 0.5. Well, if he is jumping off of a diving board and jumping into this water, it can't possibly take him negative seconds to do this. So it must take him 1.44 seconds in order to hit the water. Okay, so let's just go ahead and check this real quick. I'm going to go to Desmos, okay, and I'm going to turn on the equation, or actually I don't even have it typed in. I'm going to go ahead and type in the equation. Let's go back to our original equation, negative 16x squared plus 15x plus 12. And I'm going to go ahead and see if I can find out when he hits the x-axis. You can see the x-intercepts. Hopefully you can see those x-intercepts right here. Okay, we're checking our work. So I'm going to click on the first one. And the first one is at, guess what? Negative 0.51. We got negative 0.5. And the next one, which is 1.45, or what we got, which was 1.44. So just a reminder, we were finding the x-intercepts and we were doing that by completing the square.